All right, so again, your notes are going to be on two different parts. This first part is going to introduce the second half of chapter 3, and then we're going to talk about one specific part from that. You guys got that? So we're going to have we'll have one part of it, and then we're going to introduce all of it, and then we're going to talk about the specific part that we're going to work on. So we are talking about transformation in math. Transformation talks about movement or change. So in this lesson, we're going to, in this whole like half of the unit, and again, I'm not 100% sure why they put this with Pythagorean theorem. They're kind of like, it's not really a unit that necessarily makes sense, like to put together. But they put them together in this chapter 3. So they're kind of like, it's like almost like two little mini units. We had one little mini unit that we just took the quiz on Pythagorean theorem. Now another like little mini unit is all on movement and math. Why they put them together in chapter 3, I don't know, but that's what we're doing. So again, you can think of this like Pythagorean theorem isn't going to be applied in this part of it. It's just this little mini unit of transfer in math, and we're going to talk about different types of movement. There's a whole bunch of different types, but we're going to focus on 3 types in particular. The first one that we're going to be doing, and that is going to be from our lesson today, is this is in unit 3.6. We're skipping 3.5. It's not a big deal. 3.6 is called translation. And a synonym for translation is to slide. So we'll talk about 3.6 in a second after we go over all of this like big picture stuff. Then the next lesson that we'll do after that, 3.7, is talking about reflection. And then reflection is to mirror. And then the last one that we're going to do is rotation. And rotation is to spin or turn. Actually, there's one more of these. Where did they move it in the book? I should have been prepared for this. That we're going to do. It's in a different unit, but we're bringing it in this. I just forgot the number of it. Let me check real fast. Hold on, sorry. Where'd it go? Well, I forgot the number of it, but that's okay. We're going to do it in here. The last one is dilation. I forget which one that is, but I'll have it on there. And dilation is to expand or contract, to enlarge or shrink. That's right, like your eye. Enlarge or shrink. So we have different types of movement in math. So we're going to go through and talk about all these different types of movement. All right, so that's what this whole next set of chapter 3 is going to be on. And then the next lessons are going to be this first one. We'll talk about translation, explain everything with translation, then reflection, then rotation, then dilation. So now we can go on to the next part. It's probably good to just start a new page. Now we're going to talk about translation itself. Yeah, I mean, you can maybe fit it all on one. I don't know, but this might end up like going into 2 pages worth of notes because I did the introduction thing. So if it's going to end up taking 2 pages, it's a good time to go to the next page. So of all the different types, this one is going to talk about translation. Translation is to slide. And the first thing we should talk about with this is that when things are going to slide, they're going to be oriented the same way. It's called rigid motion. Rigid motion is when things stay the same shape and size, but so in rigid motion, after everything we're talking about, the same shape and size, but it will move. Get that. There we go. So, as an example, if you're blowing up a balloon, that is not rigid motion. The shape and size of it changes, right? But if you're throwing your pen across the room, that's rigid motion. The pen stays the same shape and size. It just moves across the room. So in all of these that we talked about in the beginning, the first three are shape and size stays, it just moves around. The last one, dilation, is not rigid motion. So with translation, so now we'll talk about translation in general. Oh no, there we go. So in translation, whatever it is we're moving is going to be facing the same direction. It'll be oriented the same way. It's just going to move around or to slide. So it will stay the same direction, but will slide. And I'll give you an example of that. Chess pieces. Chess pieces are an example of translation, right? So like if you look at a chess piece moving, it doesn't like you don't need to tilt it around. It stays oriented the same way. It just slides around, right? So all of this is rigid motion. So it doesn't matter how you move them, right? They're staying the same shape. They're staying the same size. You're not twisting them around or anything like that. They're just sliding around. All right, so that's an example of translation, right? So how chess pieces move around, or how really almost any board game you play, that would all be translation. They're all sliding around. So now let's get to what it's actually going to look like in your work, now that you understand what it is. The first thing they're going to do is have you graph something out, and then they're just going to give you some directions. So they're going to say like graph, and it could just be 1 point or it could be multiple points. So we'll graph like 3 points. So we're going to graph, let's do 2, 1, and we'll call that A. 4, 3, and we'll call it B. And then 1, 3, and we'll call that C. So when we graph it out, we'll put all those points on there. I'm going to give you graph paper, so you will not need to make these lines when you're doing the graph paper. So you'll go, just graph them out at first. 2, 1, put a dot, and you'll label it A. And then to the right, 4, and up 3. Put a dot, label it C. To the right, 1, and up 3. Or B, sorry. Put a dot, label it B. Or C, wow. And then in this one, they'll even have you connect the dots. So we'll make like a little triangle. And then it's going to give you some instructions. It's going to say, translate it. And then they're going to tell you, translate it to the left 2, and then down 3. They can make up whatever they want to there, but they'll tell you left and right, up and down, or one or the other, or both, like I just did. All you're going to do is take each dot and move it the directions they tell you. So from A, we'd go to the left 2, 1, 2, and then down 3. 1, 2, 3, put a dot. And then when you label it A, you're going to put a little line up above it. It's not a number 1. It looks like the number 1, but it's not. It's like a dash mark. The way that you say this is that you would say the image of A. So in this, we would say we have point A, and then we have the image of A after we moved it. So we have A and the image of A. You can think of it like this. If you look in a mirror, I don't know if you guys know this, but the person in the mirror isn't really you. It's the image of you, right? You don't exist in the mirror. I hope you guys get that, right? So there's you, and then there's the image of you. So it's the same thing with this. We have A, and then we have the image of A. And the other thing you're going to need to do is say its new location. So its new location is at 0, -3. And we're going to do that with all of our points. And then point B, to the left 2, 1, 2, and down 3, 1, 2, 3. Put a point here, label it the image of B, and then say its new location. To the right 2, and it's up and down 0. And then the same thing with C. To the left 2, down 3, 1, 2, 3. Put a dot, label it the image of C, and give its new location. -1, 0. And then we can connect the dots. So now we have the image of the triangle, and we have the image of the triangle. Now, so again, image of, that's how we're going to say this. The image of A, the image of B, the image of C. That's what those little lines mean. Now, they have 2 different ways to write this out. They could write it out in English, but they can also write it out in math dork terms. So now we're going to write it out in a dorky math way. It's called arrow notation. In arrow notation, the way that it always looks is they're going to describe this rule, but in dorky math ways. The way that we do it is like this: X, Y, which just means like the location of the point, like this, right? X and Y, the location of the point. And then you put an arrow. And then in parentheses, we're going to say what we're doing to each location. So let's think about this. For the X, when I moved it to the left 2, right? Let's look at what happened with A. The X in A. When I moved it to the left 2, it went from 2 to 0. In math, how did we go from 2 to 0? What did we do? Anyone know? Yeah, what did we just say? What did we do? I know we moved it to the left 2, but how do you go from 2 to 0 in math? Yeah? What's that? So let's think about an operation. What did we do? Did we add, subtract, multiply, divide? What did we do? Yes? You subtracted 2. So the way they write that is x minus 2. Now, when we went down to 3 for the y, we just subtracted 3. So this is arrow notation. The English of this is left 2, down 3. So this is English. This is arrow notation. So let's be clear about what arrow notation does. The X talks about how it moves left and right. To the left is negative, to the right is positive. The Y talks about how it moves up and down. Down is negative, up is positive. So now what I'm going to do is I'm going to give you an arrow notation and see if you guys can figure out what it would be in English. X plus 5, y minus 1. What would that be? X plus 5, y minus 1. Just say it. Right 5 and? No, not left. Down 1. You guys get it? Let's try another one. X, y, arrow, and then I put this. X, y plus 3. What's going to happen there? Ooh, let's give a guess. Yes? Sure. Now, I wouldn't have to say move it 0. So I could just say only that it's going to go up 3. Right? Because you don't need to say move left and right 0. That's just like unnecessary to say. So they'll do things in this like they'll give you English and then you write arrow notation. Or they'll give you arrow notation and you write it in English. Or they could give you the graph and tell you to do like what we did here in English. Or they could tell you how to do that in arrow notation. That's it. So it's kind of a lot of explanation. But once we get into our actual work, I'll kind of help you guys through that tomorrow. But that's everything for our notes for today.